Okay, let's read this problem carefully and try to solve it. Given two sorted arrays, nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. The overall runtime complexity should be O log m plus n. Now, it would be nice to just use a for loop, but that will produce an O of n, which is a linear time. But we need to produce O log m plus n, which can be produced either by a recursive function or by a binary search algorithm. But the recursive function will produce slightly a bigger space-time, which will be a linear time. But the binary search will provide us with a static big O of 1 of the space-time. So we should be using the binary search. They both produce the same execution time complexity, which is big O of m plus n, but the space-time is different. So the best option for us to produce more optimized result is to use the binary search. So now the problem is giving us two examples. The first one, if we have an odd number of elements, which is 1, 3, and 2. Now, we're not going to really sort the array. We'll get to the algorithm later, but imagine that the array is sorted 1, 2, 3, so the median will be just one number. Now, if we have even number arrays, which is the combined array, is produced by two similar size arrays, 1, 2, 3, 4. Now the median will be the average of the two numbers, which is 2 plus 3 divided by 2, 2.5. So the median should be defined as double. Now let's expound on the problem first, and then we'll try to jump into the code and solve it. Now let's assume that we have two arrays, 2, 4, 6 on the left side and 1, 3, 5, 9 on the right side. Now first of all, we need to find out the total number of elements, which is 3 plus 4, the length, equals 7, and then we need to define which place to cut the array. Since we're dealing with an odd number array, so we need the left side to have slightly more elements than the right side to guarantee that, and then the left side is smaller than the right side to guarantee that the median exists in the left side array and not the right side array, to narrow down the chances. So in order for us to do that, we need to find the low and the high of the first element. The low is just the case that we take no elements at all, which is 0, and the high is the case that we take all the elements, which is 3. Now, we all agreed that we should be taking 7 plus 1 divided by 2, which is 4. So the arrays that will be produced is 4 elements on the left and 3 elements on the right. And to achieve that, we need to take the length of the combined array, which is 7, plus 1 to just guarantee that we'll produce slightly bigger number on the left side, divide by 2, which is 4, right? So now we take low plus high of the first array to find out where we split the array. We're not going to really split it, but virtually speaking. So low plus high is 3 divided by 2, since we're dealing with integers, so the result will be the floor of this integer, not 1 plus 1.5, but just 1. Okay, so we take one element, now 2, this is the first try of course, and then we complement it with 3 elements from the right side array, which is 1, 3, 5. And then each array will be divided into 2 sections, the left and the right, the left and the right. So if we take just 2, that means the left parts of the right array will be 4 and 6. And if we take 1, 3, 5, so the left part is just 9. So now we compare the maximum of the left, which is 1 element in this case, with the minimum of the right of the other array, which is 9. So 2 is less than 9 is correct. And now we do the same thing. We compare the maximum of the left, 5, with the minimum of the right, which is 4. So, but 5 is bigger than 4. And in order for us to guarantee that all the minimum elements exist on the left side, the maximum of the left should be less than the minimum of the right. So this violates the rule. So in this case, we need to adjust this bar to the right, slightly to the right, to compare 6 with 5. And in order for us to do that, we need to adjust the low value, which now will become 1. So 1 plus 3, 4, divided by 2 is 2. Okay, so now we take 2 to the left, 2 and 4, and just 1 to the right, which is 6, and 2 from the left, 1, 3, and of course the remaining part is 5 and 9. Now we compare the maximum on the left, 4, is less than the minimum of the right, which is 5, correct, and then the maximum of the left, 3, is less than the minimum of the right, 6, and now this will produce the correct result. Okay, now let's jump to the code and see how we can implement this. First, we need to make sure that the array on the left side has a smaller number of elements than the array on the right side, because we're doing all the comparisons based on the smaller element array. Okay, so how do we do that? First, we say if nums1 dot length is more than nums2 dot length. Okay, so we need to switch it. Return this signature of the name of the function, find the median sorted array, and then we first pass in nums2 if it was smaller, and then nums1. Okay, now in this way we guaranteed that the small number element will be taken the first. Okay, and now we need to calculate the array length. So var array1 length, which is nums1 length, and then var array2 length, nums2 length, and then of course we have the total length equals array1 length plus array2 length, and we have the median, I'm just going to define it as Boolean equals 0.0. So not Boolean, I meant double, sorry. Okay, and now we have the low, which is 0, and we have the high, which is the maximum of this array, so will be array1 length. Okay, and now we do the while low is less than or equal high. Okay, and now the first thing is we need to define where to split the first array, and how do we split the second array as well. So the first array is low plus high. To guarantee the priority, we just put them into parentheses and then divide by 2. And for the second array, we split them based on this equation, the total length plus 1 divided by 2. Okay, and then minus array1 split. Array1 split. Okay, all right. And now we need to define also the left sides and the right sides. So we have array1 left side, and the array1 left side, first we need to check if the array1 split is more than 0 or doesn't equal 0 because if it is 0, then it will violate the whole rule and I won't be able to retrieve any elements. So array1 split does not equal 0. If this is true, then we take in nums1 of the array1 split minus 1. Otherwise, we just take in the maximum or the minimum value of integer. Okay, and in the same manner, we define array1 right side, but this time we check if it's more than the length, array1 length, Okay, more than or equal, because if it equals the length, then there's no way that we can retrieve this index. The index will be out of range. Okay, otherwise we retrieve the maximum value. In the same way, we render the second array. Okay, and now we need to check if the array or the total number of elements are even or odd. So if it's divided, or the modulus of 2 equals first if it's an odd number. So if it doesn't equal 0, that means it's an odd number. Okay, and if it's an odd number, then we'll move to the next step of checking whether all the left sides are less than the right sides. So the left side of the first one should be less than or equal the right side of the next one, and vice versa. The left side of the second one and should be less than or equal the right side of the first one. Okay, yeah, this is true. And if this is correct, then the median will be calculated using math.maximum of the left sides. So array 1 left side, and then array 2 left side. Okay, and then return the median. Okay, and of course, if this is not true, if there is any violation, so let's assume that array 1 left side is bigger than the right side. And if the left side in anyhow is bigger than the right side, then what we need to do is we need to shift the bar to the right. So we need to adjust the high to make it array split, array 1 split. Okay, -1. Okay, so this is how we adjust the high. But if the array 2 left side is bigger than the array 1 right side, we need to adjust the low. So else we need to shift the bar to the right side. So we need to adjust the low equals array 1 split +1. Okay, and now of course, if we are dealing with even number, we need to do exactly the same steps, but the median will be calculated slightly different. Plus math.minimum, because it's the average of the two numbers. The minimum of the right side, because the minimum of the right side will be the farthest left from the right side array. So, and then we divide them by 2. Okay, and now if we couldn't produce any results, we just return 0. Okay, let's try to pass in some values to check our algorithm, and this is solution dot find median, and then we just pass first. Okay, let's pass this 1, 3, and 2. Okay. Okay, so there is a problem with the right side. It says index was outside the bounds of the array. Okay. So there is with this comparison, it should be like less than or equal. Okay, and here should be less than or equal. And I just found out that this is an error as well, because this should retrieve double, but since it's divided by integer, so it will retrieve an integer number. So to guarantee that it retrieves double, we should divide it by 2.0. Okay, and this shouldn't be equal, because if it equals, then it will be outside of range. So now, okay, now it retrieves the correct result. Okay, let's try this one. 1, 2, 3, 4. Okay, 2.5. Let's try 2, 4, 6. The example 2, 4, 6 with 1, 3, 5, 9. 1, 3, 5, 9. That should retrieve 4. Okay, now it's correct. Thank you.